Hi, my name is Tiana Smith,
And I'm Kenya Gardner.
and our project was the analysis of acetylsalicylic acid from different consumer brands.
Aspirin is one of the most common ways to prevent strokes and heart attacks, though it has been shown to be harmful to those that are 70 or older. Unfortunately, it was able to kill around 3,000 people or more per year. The main thing that the question focuses on is what brand of aspirin has the least / harmful amount of impurities. In this project, it is hypothesized that the Walgreens brand has the least amount of impurities. It will also include a matching morphology structure that will also be compared to a regenerate grade aspirin and have a very close melting point. 4 series of tests will be performed for this experiment, such as pH, melting point, ferric nitrate, morphology. Afterwards, the result from this test will be compared to the hypothesis.
Aspirin being one of the most commonly used over-the-counter drugs and the most important pharmaceutical achievement that has ever happened, and it dates back very far. About 3,500 years ago, willow bark was chewed on by the Sumerians and Egyptians, and they also used the willow bark into a tea to ease childbirth. In the 18th century, Edward Stone, an Englishman, conducted 5 years worth of tests and experiments and found that crushed willow bark could cure fever. A pharmacist, John Buckner, then found the compound salicin in the bark. A couple years later, in 1853, a chemist, Charles Gardner, chemically synthesized that compound and created acetylsalicylic acid. 40 years after the compound was synthesized, Felix Hoffman and his pharmaceutical company started to sell and label this as aspirin. The influence of aspirin grew, and it was found to have and help inflammation problems as well as pain sensations. Finding which brand of aspirin can help reduce deaths and help you get the most effect from the aspirin.
Which brand of aspirin has the least impurities based on pH, ferric nitrate, morphology, and melting points?
Our hypothesis it's hypothesized that the Walgreens brand of aspirin will have the least impurities based on its pH, ferric nitrate levels, the morphology, and the melting points, because this brand does not cause serious issues.
For the material list, it includes ferric nitrate, beaker 100 milliliters, microscope, ferric nitrate, 4 different brands of aspirin, test tubes, Bunsen burner, mercury tubes, micropipette, goggles, analytical balance machine, pH meter.
The protocol. During these 4 trials, 4 brands of acetylsalicylic acid were purchased to analyze the physical and chemical properties to determine the purity of each brand. To test the pH, it takes 0.01 of crushed aspirin weighed out on a weigh paper using an analytical balance machine. The powder was added to a 100 milliliter beaker, and 2 milliliters of distilled water was also added. Repeat that for all 4 samples. To record the pH by inserting a pH meter into the mixture. Ferric nitrate was used to test its impurities, making a solution of using 0.01 of ferric nitrate powder and 1.5 milliliters of distilled water. 4 test tubes were set up for each brand. A total of 0.01 grams of crushed aspirin went into each test tube, and then a micropipette added 2,000 microliters of distilled water. Into the same test tube, 200 microliters of ferric nitrate was added. A ferric nitrate solution was added. Test tubes were shaken to mix both of the solutions, and a Bunsen burner was used to melt the aspirin. If the liquid turned brown, it was pure. And if it was more closer to purple, it was more impure. The data from this test was then recorded. To find the melting point of each acetylsalicylic acid brand, a Mettler Toledo melting point machine was used to melt all the aspirin. Then crushed aspirin was placed onto a glass slide, and capillary tubes were used to hold 3 milliliters of each brand of aspirin, and then placed into a melting point machine. Each sample was analyzed for the specific melting point, and the data was recorded. For morphology, crushed aspirin placed onto a slide and looked at under a microscope to find the shape of the aspirin. Just talk about the data. Talk about how it works.
1, you can clearly see that Walgreens has the least amount of pH, while trial 2, it has the most amount of pH. And then for trial 3, it was still around the same amount, but it came second place. For trial 2, Rite Aid has the least amount of pH. For trial 2, you can clearly see that Rite Aid has around 4 to 5 pH. And for trial 3, Rite Aid has the most amount of pH.
For trial 1 of Bayer, it was very low in the pH level. It was very low compared to what a Renegade aspirin would be. For trial 2 of Bayer, it was a little on the higher side, but it was pretty much around the average. And for trial 3 of Bayer, it was almost perfect. For trial 1 of CVS, during the pH test, it was relatively kind of low, but a little higher than Bayer's. For trial 2 of CVS, during the pH test, it was almost at that, a little above that perfect line for the aspirin. And for trial 3, it was a little more above that as well. For melting point, the melting point averages all varied based on this, the environment they were made in. So the fact that all these melting points are relatively low for each Walgreens, Rite Aid, and Bayer could determine that when they were made from the company, they could have been made wrong. The ferric nitrates, so as we explained earlier, closer to A1 was the more pure, and closer to 4 or 5, it had a more purple color, which was more impure. The first test of ferric nitrate was pretty impure, but as the test went on during the Walgreens, it started to go down. Rite Aid had a above what it should be ferric nitrate test the first time, and then it went down, and then it spiked back up. And Bayer had one on a number 2, which was kind of a orange brown, and then they had 2 tests on like a orange color. CVS probably had a brown for the first trial, and it had a maybe orange brown color on the second trial, and it had another brown trial for the third trial. Sorry, just trying to switch this.
For data analysis, you can clearly see for a Bayer aspirin morphology, you can see the shards. For CVS morphology, you can clearly see some shards, but they're not as visible. For Walgreens morphology, you can't see the shards.
No, those are the shards.
Oh,
that is the shards. So for Walgreens aspirin, you actually do see the shards in the background a lot more visible than the other brands. And Rite Aid, you couldn't really, it wouldn't get clear at all, but you can tell that in the background of that, it had a little more shards into them. And then CVS, it was definitely had its rounder bits such as Bayer as well. In conclusion, the CVS brand of aspirin was best tested and had the least impurities based on a 2 out of 4 scale. The ferric nitrate test was more closer to a yellow color, and the morphology of the aspirin was more circular than the others. However, Bayer had a lower pH and Walgreens had the closer melting point to 140 Celsius. Based on the data analysis, the hypothesis was proven wrong since CVS was closer to being a better aspirin over Walgreens. The worst brand overall was Bayer. It had a very low melting point because maybe how it was developed and it wasn't at the right temperature during the development in the company's lab. It was also shown to have acid in it because of the ferritin test, which came out purple, and it also showed long tube crystals in its morphology. There were a few minor issues within this experiment during morphology. Our machine that takes pictures for our microscope was freezing a lot, and there were many instances that the computer we were using would crash. Another issue was that it was identified or finding the actual shards in the aspirin. Another issue is where the melting point machine took way longer than expected due to how the capillary tubes had to be exactly at 3 milliliters. For future studies, this project would use other brands like Family Dollar, Dollar General, Myers, and Muller. And that is our project. Thank you for taking the time out of your day to watch this. Bye.